All right, so part 2, so we're still continuing our review. So now I'm going to go over the periodic table and bonding is what we're focusing on today. So these are our most recent ones, so they shouldn't be anything new, okay? So just a reminder, when I look at an element here, the top number is my atomic number. This middle symbol is just called the chemical symbol or just the symbol. And then this bottom number is called the atomic mass, right? All right, and just as a reminder, where are my metals and where are my non-metals on the periodic table? Left side or the what? We have metals on this side, and we have non-metals on this side of the staircase. What is, oh, I spelled that wrong. What is the staircase called? The staircase are called the metalloids, okay? So everything on the left side with exception of hydrogen, which is a non-metal, okay? With exception of hydrogen, everything on the left side of the staircase is considered a metal. Everything on the right side is considered a non-metal. And then hydrogen is also a non-metal, okay? When we're looking at columns or what go up and down on the periodic table, these are called groups. And periods go from side to side. So these are our rows. Groups are columns. Remember that these show us or can give us valence electrons, specifically the A groups give us valence electrons. Oh, not VA, valence electrons, not the VE. Okay, periods go, they're horizontal. So whenever I got that question a lot before, so horizontally across the periodic table, they tell us number of energy levels. Remember, energy levels or shells. Okay, so groups go up and down, periods go left and right. They each serve their purpose on the periodic table, right? And then what I want you to also remember is that groups have similar chemical properties. So if I look at this first group right here where I have hydrogen, right, and then I have like lithium, and then if you look at that first group, all of the alkali metals have similar properties, right? If I look at the noble gases, all of the noble gases have similar chemical properties. So that's what I want you to keep in mind / memorize, like keep that in mind or remember whenever if you do take the DBA this week, okay? When we're talking about bonding, so this is our most recent stuff that should be easier to remember. So ionic are between a metal and a non-metal. Covalent are between two non-metals or a non-metal and a non-metal, right? Cations are positive, otherwise known as the metal. Anions are negative, otherwise known as the non-metal. Now we spent a whole, a whole week or two? Yeah, I'd say 2 weeks, right? Naming and writing chemical formulas of ionic and covalent, right? So remember, when we're looking at the differences, naming covalent has those what in front of the words. They have prefixes, right? Remember the mono, di, tri, and they end in what? End in "ide." Okay, and then ionic, on the other hand, there's no prefixes, but we still end in what? They also end in "ide." Okay, so remember what's happening with the electrons here. So if I have H2O, for example, which is a covalent bond, oxygen goes in the middle, hydrogen, hydrogen. If you calculate, there are two hydrogens, so we have two hydrogens here. Each hydrogen has how many valence electrons? Look at your periodic table. Hopefully you memorize it now, but I have 1 and 1. Oxygen has 6. So 6 plus 1 plus 1. We have 8 total valence electrons, right? So just a reminder on how to draw these. So remember, we start with our lines, so we connect them, right? So we go 1, 2, 3, 4, and we've drawn 4 total so far. So we have 4 more to draw. Do you remember how we draw them? We draw them as lone pairs, those dots, right? And do I put the dots right here in front of, on top of the hydrogen? No, I do not, because hydrogen already has these two, right? So remember that we draw the other ones as lone pairs. You'll never see one dot by itself. So they go as lone pairs, and we're gonna draw it around the center, okay? And then if I look at everything, if I look at hydrogen, hydrogen has, because remember, one line equals 2 electrons, so I have 2. If I look at oxygen, I have 2, 4, 6, 8. Good, because that's what we want for oxygen. And then for hydrogen, we have 2. Because remember, hydrogen can only hold 2 because hydrogen is in that first period. And what do periods tell us again? Number of energy levels. So if I only have 1 shell around hydrogen, how many electrons max can it hold? 2. So that's the only reason why hydrogen's good with just 2. Okay, that should be a review. That's why I'm moving quickly. This is a review. So, and remember that these lines show that we are sharing valence electrons here. Remember, line is showing sharing valence electrons. On the other hand, when we have ionic bonds, if I'm drawing NaCl, for example, okay, and I have Na here and Cl, sodium has 1 valence electron, chlorine has 7. So 1, 2, 3, 4, 5, 6, 7. Okay. And remember here, there's no sharing. Sodium is going to give its electron to chlorine. And when it does that, sodium becomes positive or negative? Positive. Remember, metals are always the cation. So positive, and then chlorine becomes negative. Okay. So here, there's no sharing of valence electrons. There's gain or loss of valence electrons. And we'll put a star there. Okay. And then just a review of the other stuff we've been talking about. Poly means what? So means many. So we have one ion, many atoms. And remember, for these, we don't follow, even though these are all under ionic compounds, we just use our chart. Use chart to name it. We don't change the ending. Remember that. And you look at your chart for the charges as well. Okay. As for the transition metal, what's key about them is that they have a Roman numeral in the middle, right? That show what? Roman numeral shows charge of metal. Okay. And it applies to like the other metals as well. It's usually just the metals that have more than 1 charge, right? You'll see that pattern throughout. So that's our little review for the day. And this is what you're going to be using to complete your practice for today. That had we been in person, you would have the whole class to work on. It should be pretty straightforward. But again, if you need some extra help or want some clarification, or just some reminders of stuff you've forgotten, I'm on Zoom, guys. So come see me on Zoom. As long as it's during those hours, I'll be there. Okay? All right. Thanks.